Hey everybody, we're going to do a little bit of division today. So we're doing R.3 dividing polynomials. First thing that I need you to take note of is this vocabulary word that we learned just a couple days ago, monomial. Do you remember that just means one term? And so what I want to emphasize here is look at these first two examples. Those are both monomials in the denominator. And so I'm going to fast forward to these couple examples down here. Notice the denominators of these. Not monomials, right? These are actually all binomials because there's two terms down there. So just kind of remember that there's a huge difference when we're doing our division here. So when you're dividing by a monomial, that's actually much easier. And what we're going to do is we're going to separate into individual fractions. And then just reduce. So these are actually really easy. They're very simple examples when you separate your fractions into individual reducible fractions. So what we're going to do is we're going to take our 6a over our negative 3, and we're going to take our 9b over our negative 3, and we're going to take our negative 12 over our negative 3. I'm going to separate all of those out. 6a over negative 3 plus 9b over negative 3 minus 12 over negative 3. And then all I have to do is reduce those fractions individually. So this first fraction just reduces to negative 2a. And then my plus 9b over negative 3, that simplifies to just a negative 3b. And then my negative 12 over negative 3 simplifies to positive 4. So that is actually the simplified version. Notice that there are no like terms that we can combine there, so we're finished. You just divide all of three of the terms in the top by negative 3, and that's it. So let's do the second one the same way. Again, we're going to separate into 4 different fractions because there's 4 terms in the top. So I have 25x to the 4th over 5x minus 10x squared over 5x, 15x over 5x, minus 5 over 5x. And I'm just going to reduce all 4 fractions individually. So I'm doing my numbers and then also my x's. So 25 over 5 is 5. X to the 4th over x is x to the 3rd. One of them cancels. I have negative 10 over 5 is 2. X squared over x is x. In the third fraction, 15 over 5 is 3. And the x's both cancel, so that's nice. And then in the denominator, you have to be careful for this last one. The x is in the denominator. It needs to stay in the denominator. The 5's both simplify to 1. Negative 5 over 5 is negative 1. Keep in mind that x stays in the denominator. So actually, now that we've divided these, this is not a polynomial anymore because I have an x in the denominator. All right? So just dividing them individually, no big deal. What I'm going to go to now is I'm going to review a little bit of division that you might have learned back when you were in elementary school. So I'm going to go over this example over here, which might seem kind of funny. But we're going to do that one first because the process for these are exactly the same way as we're going to do this, which is what we learned in elementary school. So I'm going to go over that very slowly and very carefully so that you can kind of remember the process when you're doing that. And then from there, we're going to apply the same exact process to these harder examples with our binomials and trinomials and our polynomials that we're dividing here. So think to yourself, how would you divide this if you were going to divide? Also, side note, did anyone just hear Boiler bark? That's because I'm in my house making this video for you. Anyways, you might hear him bark again. No big deal. What we're going to do is we're going to, first of all, try and figure out if 4 can go into 2. 4 does not go into 2, so what do you do then? You see a 4 goes into 22. And it does go into 22, not evenly, but how many times can you put 4 into 22? You can put it in there 5 times. And notice I put the 5 over the 2 of the 22, the second 2, just so I can keep everything lined up. I'm going to keep everything really lined up when we do the more advanced examples as well. So what I'm doing now is I'm multiplying 5 times 4, and I get 20. And I write it underneath, and then what do? And so I know a lot of you remember you're supposed to subtract here. And this is a really, really, really important part, subtract. And that's where most people get confused when we do the harder examples. So just keep that in mind. And so when I subtract 22 minus 20, I get a 2. Okay, and so then do you remember what to do? you bring the 9 down, right? This is the same exact process that we're going to do when we do the harder examples. So now the question that we're asking ourselves is, how many times does 4 go into 29? And so again, same kind of process. It doesn't go in evenly, but that's okay. 4 goes into 29 7 times. And then we do 7 times 4, which gets us 28. And then again, remember, we subtract that, and we're left with 1. Okay, so I'm going to make another arrow here. Remember to subtract. This is the hardest part for most people when we're doing our long division problems. And so I remember probably when I was in, I don't remember when I learned this, maybe 3rd or 4th grade, that we would write our answer with remainder 1. Do you remember that part? So we are not doing remainders anymore. There's a better way to write your answer, okay? So we actually take the 1 and we put it over the divisor of 4. So just keep in mind this 4 is this 4. That's how you write your remainder from now on. The answer is 57 and 1/4. And this is the same process that I wanted to review so that we're able to do our harder examples now. Okay, a couple of things that I want to emphasize first before we dive right in is that what we have to do is first write the polynomials in standard form, which means decreasing order or descending order. And then something that's really important is that you need to fill in missing terms with a 0. And what that means is, can you notice that in this problem there is no x to the 3rd? So when I actually set up my long division, I'm going to put in 0x to the 3rd because there is no x to the 3rd term in this polynomial. And that's going to help keep everything lined up and nice and neat so that I can divide really easily using that same process. So it's kind of a little bit of writing. It's going to be a ginormous problem here to get set up, but I'm going to actually write x plus 3 and then a giant division bar. And I'm going to write all my terms in there from the numerator. So x to the 4th, there's my 0x to the 3rd. It's going to help me keep everything lined up. There is no x to the 3rd term, so that's what I mean by fill in missing terms with a 0. Plus 3x squared plus x plus 4. And what we're going to do here is we're going to do the same process that we did earlier. So again, all we're trying to think about is I want you to just focus on this x. How many times does the x go into x to the 4th? Remember in that first example, we just started with the 4 and the 2. It didn't go into the 2, so then we moved to the 22. Same thing here. What do I need to multiply x by to get x to the 4th? That's what you're asking yourself. And so I know that I have to multiply that by x to the 3rd. And so now I'm going to multiply, just like I did in the last example. X to the 3rd times x is x to the 4th. And x to the 3rd times 3 gives me 3x to the 3rd. And then remember, here's the really tricky part, is that what are we supposed to do now? We're supposed to subtract, right? That's what we wrote on that last example. So what I like to do in a different color is subtract. And the tricky thing is that we're subtracting both of those terms. So x to the 4th minus x to the 4th is 0. That's what we wanted. But you have to be really careful with this negative sign. You're actually changing it on the 3x to the 3rd as well. You have to subtract both of them. You're subtracting the entire parentheses. So 0x to the 3rd minus 3x to the 3rd gives me a negative 3x to the 3rd. Okay, so that subtraction part is really tricky for most people. Now what do? Bring down the 3x squared. And it's a positive 3x squared, so I'm writing plus 3x squared. And now again, we're going back to the x. What do I need to multiply this x by in order to get it to be negative 3x to the 3rd? And what I need to multiply that by is I need a negative 3 and I need an x squared. So that when I multiply negative 3x to the 2nd times x, I get this. That's the goal. And I'm going through this very, very slowly, and we will do a couple examples in class tomorrow. So if you're confused, just try and stay with me, copy this down. And after we do a couple more, you might get the hang of it. So negative 3x squared times x is negative 3x to the 3rd. And that's what we wanted. You want those two terms to match. That's what we want here. And now I need to do the negative 3x squared times 3. Negative 3x squared times 3 is negative 9x squared. And again, now we're subtracting. So when I subtract that entire thing, you'll see that the 3x squareds cancel out, and that's what we wanted. And now what I need to do is distribute that negative sign to the 9x. So I'm actually doing 3x squared minus negative 9x squared. So it actually changes to a plus. That negative sign is going to change this to a positive, and I end up with 12x squared. And then again, now I bring down the x, and it's a positive x, so I'm writing plus x. And now I'm thinking, what do I need to multiply x by to get 12x squared? And I need to multiply that by 12x. And so now I do 12x times x is 12x squared. I want those to match, that's the goal. And 12x times 3 is 36x. Now again, I need to subtract. And the 12x squareds cancel, but I'm now doing positive x minus 36x. That's going to change that 36 to a negative, and I end up with negative 35x. Last thing is to bring down the 4. And what do I need to multiply the x by in order to get negative 35x? I need to multiply it by negative 35. And I'm going to go through my division or multiplication one more time. Need a little bit more room. Negative 35 times x is negative 35x. And negative 35 times 3 is negative 105. Need to subtract. My negative 35x's cancel. And then I have positive 4, and then I have this negative and this negative. So it changes to a double negative, which makes it a positive 109. And remember how to write our answer. We don't write remainder 109, you write it as a fraction. So I'm going to write plus 109 over the divisor, which is x plus 3. So that was a really long, kind of slow process, but it's very, very simple if you can just remember the process that you learned when you were in middle school, okay? Let's try one more, and then we'll do another one in class. Here's our last one. All we're going to do is I'm going to go ahead and get this set up. I'm going to write the 2x minus 1. And I'm going to do a quick check and make sure that I don't have any missing terms in this one. I do again have x to the third missing, so I need to put in a 0 for that. Remember that. So I have 4x to the fourth, 0, x to the third, 5x squared, 2x, and 4. So first thing I'm asking myself is, what do I multiply 2x by to get 4x to the fourth? So what I'm going to multiply by is 2x to the third. And that's what's going to give me my 4x to the fourth, which is what I want. And then 2x to the third times negative 1 is negative 2x to the third. So it's something you should be thinking about is, what if you didn't put that 0x to the third in there? Then you wouldn't have your numbers lined up. And that's why that part is really important. So I'm going to subtract. Those cancel, and I have 0x to the third minus negative. That's a double negative, which changes to a positive. Bring down the 5x squared and do it again. So I need to multiply this by just x squared. That's going to give me my 2x to the third. And x squared times negative 1 is negative x squared. Subtract. Cancel. 5x squared minus negative is a double negative, which changes to a plus, so it makes it 4x squared, negative 4x squared. Bring down the 2x, and we're almost finished. So now I have negative 2x that I need to multiply the 2x by so that I get negative 4x squared. You always want those to match. And then negative 2x times negative 1 is positive 2x. And something a little crazy is going to happen here. When I subtract negative 4x minus negative 4x, that cancels. And when I do 2x minus 2x, that also cancels, so I just have 0, which is weird. And then bring down the 4. Well, what can I multiply 2x minus 1 by to give me 4? Nothing. So the 4 is just your remainder. Okay, so the remainder is, actually I'm going to write my answer over here so it's a little bit nicer. 2x to the third plus x squared minus 2x plus the remainder is 4 over 2x minus 1. So there's nothing that I could have multiplied the 2x minus 1 by to give me the 4. So I know that I just have a whole number left over, and that's my remainder. So a little bit trickier there because everything canceled out, but Still the same process, okay? We'll do the last one in class tomorrow, and I'll be able to answer whatever questions you have, okay? See you later.